Hi everybody, this is a quick video for JSEVIER21. He asked me how I made my 12 volt adapter that plugs into my car cigarette lighter to keep the computer alive while you unplug the car battery. Well, this is it. I've taken the tape off the one I have the 12 volt adapter, and basically from the 12 volt adapter there's two wires. You can split them apart, and one of the two wires has often a colored strip, like a bar, a dotted bar that goes along the wire. That's your positive voltage wire, so that's the positive 12. What I did was I cut the wire and I soldered in a diode. I'll tell you what that is now in a second. But the diode has a little round black body with a gray bar or a colored bar, and the colored bar is on this side of the body, and that's wired in line with this wire that has the dashed bar on it, and then that goes to this part here, and the dashed line, the positive 12 volts, that comes out on the center connector here. On this thing here, this is the negative, so this one here would be connected to the other wire, which is not dashed and colored, and that would go back to the adapter. And so this diode, what is that? A diode is basically a one-way valve for electricity flow. That's all you need to know. Let me explain it to you on paper. Okay, so this is your 12 volt adapter, and you have this dashed line that comes out, and there's 12 plus 12 volts on this. So this would be your positive, and this would be your minus wire coming out of your 12 volt DC battery. It has to be direct current, DC. Okay, so then the dash wire comes out here. Then you've got this diode. I used diode part number 1N4001. You can get this at Radio Shack or Fry's Electronics or whatever electronics store that you can find that sells consumer electronics type stuff. Okay, so then you've got your diode. Then that will be twisted. You can twist the ends of the diode onto the wires of your plug that goes into the cigarette lighter. Now this wire will directly connect up to this positive terminal. And then this negative side that goes to the side of the cigarette lighter, that goes back through this wire and then comes back into the adapter. Now, when you hook this up, you should get a plus 12 volts from here. This is plus 12 with this as your negative voltmeter probe, and your car obviously would connect up to this. So this is one way you can do it. I used a 500 milliamp adapter, so 500 mA is the current rating for the adapter, and it's 12 volt DC coming out. Another way that I think would be better would be to, instead of using the 12 volt adapter, use two big 6 volt lantern batteries. So these batteries could be for example, like the big flashlight batteries, and you would take the positive of one battery, connect it to the negative of another battery. Then these two batteries gives you a full 12 volts, and this should provide a lot of current for quite a while for your car computer. Then you would take your negative, and that one would just go connected to the negative on this guy, and the positive would go through the diode, and then that would connect up to here. So why do you do this? Well, tell you the truth, why do you put this diode in the first place? Well, tell you the truth, it's the diode prevents, well, I don't want to get ahead of myself here. Let me explain it to you with this sheet of paper. The diode is a one-way valve for electricity, like I said. So typically current will flow from the plus through the circuit and back to the minus. So when you hook your 12 volt source, whether it's in your adapter or it's your 12 volt, two batteries hooked up, current will flow in this direction. The diode will not let the current flow backwards. So the current has a flow here and come back this way. So when the current flows this way, when you hook this up to the circuit, your car battery, this huge battery with a huge capability to deliver current, will see this 12 volts. Maybe this is 12.2 volts and this is 12 volts. Well, actually this would be more like 12.6 volts. So this guy will try to force current into the battery, and that will burn this guy up. So this diode prevents the electricity from flowing, from the current from flowing back this way, because it's like the one-way valve for current flow. So the electricity will flow this way, and basically if this guy is more powerful, higher voltage than this one, the current won't flow back this way. So when this guy is hooked up to the computer in your car, just the same time this guy is hooked up, this guy will feed the car its voltage instead of this guy, because this guy is slightly higher, probably 12.6 volts, something like that. Now when you disconnect this guy will immediately take over. So the purpose of the diode is to prevent the current from the car battery flowing into your little battery that you're trying to hook into the cigarette lighter. In hindsight, I would prefer to use this system here where you have two batteries, because I found that on my car, when after you wait some period of time, the alarm system or something like that may start to pull, and every now and then it would suck a spike of current out of the battery to do whatever it has to do, then it would turn itself off. And I started to get voltage variation out of my system, out of the adapter, and I think two batteries like this would be a better solution. But you would need the diode. Now, having said that, doing this with the adapter and the diode, I think the diode is probably redundant and not really necessary, because in the 12 volt adapter, now I don't know exactly what the details are inside this, I didn't take one apart, but in most AC, alternating current to DC, direct current transformers, or you want to call it a rectifier, basically what you have is you have a transformer in here and some pair of diodes in here, and the pair of diodes takes a waveform that goes like this and turns it into a waveform that goes like this, right? So you would have something that's alternating current up and down. So this is your 0 point here, your 0 point is here. So, but I mean, what I'm trying to say here is that there are diodes just like this guy already inside here, and that should prevent a car battery from flowing back into this guy and destroying this guy. I put the diode in just as a safety precaution because I didn't know exactly what was in here. But if I was really stuck and desperate, I probably would just hook this directly up to the 12 volt DC adapter and just pray that inside there are diodes that would prevent this guy from flowing in here and melting wires or burning thing up or making the thing explode. But like I said, you could probably get by without putting this in line with a DC adapter, but you're going to need it if you use batteries instead of the DC adapter. So the last thing I can think of is that this diode, like I said, it's a 1N4001 is the one I chose. It's probably not too critical which diode you pick. You want to pick something that can handle a forward current of at least 1 amp. So you want 1 amp diode or bigger. I mean, these things come in very large sizes that can handle very high currents. You can use the biggest one possible you can find if you want, but like I said, you probably only need to handle maybe an amp, maybe two. Other parameters for diodes are the voltages and stuff like that they can handle, like the reverse voltage, which would be what you could put it back in the opposite direction to make it fail and make it pass current in the opposite direction. But yeah, just pick any old diode that can handle like 1 amp or something like that, something higher, and try it out. That's it.